So, good morning, students. Welcome to lecture 4 for units and measurements. In the previous lecture, we have studied another applications of dimension, that is how we can derive the relation between the physical quantities if we know the factors on which that physical quantity is depending. So we can use the dimensions and their concepts to derive up the relationship between the quantities, and that's what we have done. We have solved certain examples, and in the previous class I have left you with this slide. So this was the homework that I have given to you to think about this, and I hope that a lot of you people have done it. Some of you have also sent me an email, and I am really very happy about that you people are responding to me for your homework also to my email. So it would be better for me that I'll be expecting some more outcome from you people, and some more responses will be appreciated. Please keep in mind that whenever I'm giving you some homework, try to solve it up, take a picture of that, and then send me to the email. I'll be just responding it back after checking the homework. So let me solve this thing for you. Those who have not solved, let me solve this thing for you. All right. So it says this thing, that the frequency of vibration of a stretched string, that is nu, it depends on 3 factors, and we need to find an expression for nu. The answer has to be like this. Let's solve it. Okay. So this was the question, and let me solve it for you people. According to the question, we can write that nu is directly proportional to L. So we can write it like this: nu proportional L to the power A, because we don't know that how this nu is proportional to L. We know this thing that it is depending on L, but we don't know that how it is depending. All right, whether it is depending to the directly to it, or to the square of it, or maybe cube to the L, or square root of to the L. We don't know about this. So that's why we have put nu proportional L to the power A. It's nu, it's not a V. It's nu, that is the symbol for frequency. All right, and it is also depending on the mass per unit length. So nu proportional m to the power b. This m is not mass, but it is mass per unit length. That's why we need to use the dimensions for mass per unit length, and I have given you that thing in the hint as well. And nu is also depending on t to the power c, where t is your tension. That's what we know. Now combining these 3 equations, we can write it like this: that nu proportional L to the power A, m to the power b, and capital T to the power c. This capital T is not time, it is tension, and tension is some kind of force. Now we need to write the dimensions of all the quantities that are involved. All right, we can write this equation like this also after removing the proportionality sign. So there will be one constant, that is k. So nu becomes equal to k L to the power A, m to the power b, and t to the power c. Now let's solve it. How we can solve it? We have to write the dimensions of the quantities that are involved in the equation, both the sides, because by the principle of homogeneity, the dimensions of the quantities that are involved in equation, both the sides must be equal. So that's what we have done. We have written this dimensions for the nu, that is t minus 1. Nu is frequency, that is t minus 1. The dimension for L will be capital L only, and for m it is m by L, because it is mass per unit length. And for tension is some kind of force, so it is mlt minus 2. So that's what I have done. In place of t minus 1 is the dimension for this nu. So in place of nu, I have written t minus 1. L is the length, so the dimension will be capital L only. Small m is mass per unit length. That's why the dimension will be ml minus 1, m upon L. All right, and the power remains the same, that is b. Similarly, for tension T, it is some kind of force. I have written mlt minus 2 to the power c. All right. Now we need to separate the terms with the respective powers. So separating it out, I can be writing it like this. Over here, L is having power A. Over here, L is having power minus B. And in the third term, L is having power C. So I can write, when the coefficients are same and power are different, I will be adding up the power. So in place of the power to L, I can write A minus B plus C. For M, here the power is B, and in the third term the power is C. So I can write M to the power B plus C. Similarly, for T, C is only involved in third term. So I can write minus 2 to the power C. All right, minus 2C. T to the power minus 2C. That's what I can write. And now comparing both sides. So both the sides, the power must be equal. So comparing both LHS and RHS. Here, no M term is involved. Also, no L term is involved. It means the power of M in the equation towards the left hand side should be 0. Similarly, the power of L should be 0 in the left hand side. So also the power of M and L towards the right hand side has to be the same. So B plus C equal to 0 and A minus B plus C is also equal to 0. All right. So you can write it like this, and this minus 2C is the power of T and minus 1 is the power of T in the left hand side. They must be equal. So minus 2C is equal to minus 1. So this is our first equation. B plus C has to be equal to 0 because no M term is involved, and A minus B plus C, that is the power of L, has to be equal to 0 because towards the left hand side the power of L is 0. So the three equations I got. From this I can get the value of C, that is C equal to half, and from this I can get the value of B, that is B equal to minus C. All right. So I can write it like this. From first equation, C comes out to be half. Now from the second equation, B is equal to minus C. And when B is equal to minus C, C value I have just obtained in the previous equation. So C equal to half, I can put the value of C, that is equal to minus half. So B becomes equal to minus half. Now the value of A, you can solve this equation. So A is equal to what? A is equal to B minus C. This B will go towards the right hand side and it becomes plus, and this plus C will become minus. So A becomes equal to B minus C. In place of B, I can write minus half, and in place of C, I can write half. So minus half, it becomes minus 1. So the value of A comes out to be minus 1, B comes out to be minus half, and C comes out to be half. Now put these values in equation number 5. All right. So let's put these values in equation number 5. You will be having this thing, that mu is equal to K. In place of A, I have written minus 1. In place of B, I have written minus half. And in place of capital T, I have written half. That is the value of C. So C is half from the equation we got. Now, just rearranging the terms, this L will go in the denominator, and this M will also go into the denominator because the powers are negative. So it becomes like this. K upon L, and M to the power half is root M in the denominator, and T to the power half is root T in the numerator. It becomes like this, that whole root T by M. So this was the final required expression for this question. Here's the solution for this one. And it has to be equal to this, like, or let me take one question. Someone has written something. Let me take that one first. All right. Yes. All right. So Barkha wants this thing that it needed to be explained again. So let me ask Barkha that what exactly she was not able to get, or I'll be just explaining it again. No doubt about it. So let me ask her that what her doubt is actually. All right. So Barkha wants to know this thing, that after this thing, she was not getting it. So let me explain it again. That see, over here, L is having power A. In this complete term, L is having power B. All right. And in this complete term, L is having power C. So in this thing, that we have to see the powers of the quantities that are involved in the left hand side and the powers of the quantities that are involved towards the right hand side. This is having L to the power A, and now when you solve this, it will become M to the power B and L to the power minus B. All right, you can solve it, and when you solve this, it becomes M to the power C, L to the power C, and T to the power minus 2C. All right, now when the powers are different and the coefficients are same, we can add up their powers. Like x square multiplied by x cube, we can directly write it as x to the power 2 plus 3, that is x to the power 5. Similarly, the coefficients are same over here. L is having power A over here. Over here, it is having power minus B, and over here, it is having power C. So I can add their power. That's why when they're separating them out, I have written it like this, that L is having power A minus B plus C. So that is the case. Similarly, M is having power B over here, and in the third term, it is having power C. So I can write M to the power B plus C. That's what I've done. And C is only having power minus 2C. So it is, I have written it over here. Now when I compare it up, B plus C, it is equal to 0 because no M term is involved in the equation towards the left hand side. No M term was involved. So it is, I can write it like M is having power 0 over here. So the power has to be equal in both the sides of the equation. So B plus C is equal to 0. Similarly, L term is also not present towards the equation in the left hand side. So we can write L is having power 0 over here because something raised to power 0 is 1. If you are multiplying some quantity with 1, we are getting the same quantity back. So I can write it like this, M0, L0, T minus 1. All right. So now L is also having power 0. So I can write A minus B plus C is equal to 0. That's what I have written. And C equal to minus 2C, but the T power is minus 1. So I should be writing minus 2C equal to minus 1. That's what I've done. Now I have solved it for A, B, and C. All right. So C is equal to half from this equation, and B plus C equal to 0. So B becomes equal to minus C, that is equal to minus half. All right. And in this equation, A is equal to B minus C. The value of B was minus half and the value of C was half. With this minus sign will make that minus half. So value of A becomes equal to minus 1. Now I need to put these values in equation number 5. So the value of L to the power A is L to the power minus 1, M to the power B is minus half, and T to the power C, that is half. Now solve it up. This L will go into the denominator because it is having power minus. Similarly, M will go into the denominator, it is having power minus. All right, but the power is half, so root of M will be there. And T is also having power half, so root of T will be there. So we can make it whole root T by M and K by L. So this is the final required expression. I hope it is clear to you, Barkha, now. So this is how you need to proceed for the dimensions in which we need to find the formula for some physical quantity if we know the factors on which that physical quantity depends. All right. So this we have done in our previous class. Now I am giving you some practice problems. So these are the practice problems that you have to do. So I'll be sending you this PDF. So you can easily be doing it. I have also written the answers for it. So answer 1 will be like this and answer 2 will be like this. So you have to do it. All right. So this is your practice problem. And if you solve these practice problems and mail me back so that I'll be checking it out. If you are having some doubts and problems, I'll be just solving them on the mail itself. You can also be calling me sometime if you want. All right. So this is how you need to proceed for the dimensions. And please solve these practice problems and mail me back at my email ID. Okay. Now let's move towards another application of dimension. That is the third one. That is to check the dimensional consistency of an equation. We can apply this dimension knowledge to some equations, and we can check that whether we have written those equations correctly or not. All right. So by the principle of homogeneity of dimensions, we know this, that the principle of homogeneity of dimensions says that both the sides of the equation must be having the same dimensions in the terms that are involved in the equation. All right. So we can easily be using this concept to check the consistency of an equation, whether the equation is correct or not. That we can actually find out by applying the principle of dimension. So let's solve it with the help of examples. So we'll be getting a better understanding of the fact that how we can check this consistency of an equation. Let's do example number 1. It says check the dimensional consistency of the following equation: S equal to ut plus half at square. This is the equation of motion, second equation of motion. We know S is your distance, u is initial velocity, t is time, a is acceleration. We know this. We have studied this equation. We have to check this, that whether the equation is dimensionally consistent or not. In order to check this thing, what we need to do is we have to check the dimensions of the terms that are involved towards the left hand side and the dimensions of the terms that are involved towards the right hand side. And if both the dimensions are equal, it means the dimensions of the RHS terms are equal to the dimensions of the LHS terms. then we can say that the equation is dimensionally correct, or we can say the equation is consistent. All right. So let's do this. Solution 1. Dimensions of terms involved in left hand side. So in the towards the left hand side, only one term is there, that is s. So we need to write its dimension. We know s is a distance, and distance is some kind of length. So the dimensions for s will be L. So that's what we know. All right. Now we need to find the dimensions of the terms that are involved towards the right hand side. So two terms are involved. First is ut, and second one is half at square. So let's try to find out the dimensions of ut first, and then we'll be finding out the dimensions of half at square. And if they come equal to this dimension of quantity, that is s towards the LHS, we can say this thing that the equation is dimensionally consistent. So let's do this. Dimensions of terms that are involved in RHS. So first term is ut. So dimensions of ut will be equal to what? Dimensions of u into t, dimensions of t. So t is time. We can write the dimension as capital T, and u is initial velocity. Velocity is having dimension LT minus 1. We know this. And when you solve this out, this t minus 1 and this t, they get cancelled out, and you are left with L. So ut, it is having dimensions of L only. All right. Now again, check the dimensions of the another term that is involved in the equation towards the right hand side. It is half at square, and half is a constant. It won't be having any dimensions. A is acceleration due to acceleration. All right. So acceleration is having a dimension that is LT minus 2. We know this. We have done it in our dimensional formula. The dimension for acceleration is LT minus 2, and t square, that is time squared. All right. So we can easily write for t, that is capital T square, and this t square and this t to the power minus 2, they get cancelled out. Again, we are left with L. So now all the terms that are involved in the right hand side of the equation, we have found out the dimensions for those terms, and the dimensions of the terms in the LHS, they are equal to the dimensions of the terms in the RHS. So we can say this, the dimensions of RHS are equal to the dimensions of LHS, and now we can say that the equation is dimensionally correct. All right. As both the sides, the equations have the same dimension. So this is how we can apply the dimensional analysis to check whether an equation is dimensionally correct or not. All right. So that's what we can do. It's very simple. Still, if you are having some doubt, I'm stopping a bit for a minute or something, and so that you will be asking me your doubts, and then I'll be proceeding further for the second example. So let's start with the second example. Now it is quite clear to you that how to check the consistency of an equation. You have to find the dimensions of the terms involved in the left hand side, find the dimensions of the terms that are involved towards the right hand side, and then check whether the dimensions are equal or not. If they are equal, the equation is dimensionally correct. If they are not equal, the equation is not correct. All right. So let's do another example. It says check the dimensional consistency of the following equation. Tau equal to I alpha. You know what is tau? That is torque. Alpha, you know, that is angular acceleration. And I is one new quantity to you, and this quantity is known as moment of inertia. moment, moment of inertia, inertia. All right. So moment of inertia is this I. And when we will be dealing with chapter number 7, then we will be finding out the moment of inertia for various rotational motions, or various objects that are having rotational motions. So for that, we will be finding the moment of inertia. Till now, I'll be just giving you the formula for this. All right. And then you will be easily able to write up its dimension and check the consistency of this equation. I have actually involved this because it requires a dimensional formula of this I, and it is quite new to you. I have not taken it in the dimensional formula that I have made you write in the notebook. So there may be possibility that there may be some other important quantities that we will be doing when we are doing the questions alongside. All right. So here tau is torque, alpha is your angular acceleration, and I is moment of inertia. Now we need to do the solution. So let's do the solution. Torque, we write torque equal to force into distance. We know this. We have done the dimensional formula of this. So let's try to find out the dimension of the terms in the LHS, that is dimensions of torque, tau. So dimension of tau, it is force multiplied by distance. Dimension of force is mlt minus 2, and for distance we can write L. So it becomes ml2 t minus 2. All right. So this is the dimension of the term that is involved towards the left hand side. All right. Now, for the dimensions of the terms towards the right hand side, we need to know what is moment of inertia first, and then only we can write its dimension. So moment of inertia I, it can be written as mass multiplied by distance square. All right. So this is the formula for moment of inertia, capital I, that is mass multiplied by distance square. So for mass, we can write the dimension as capital M, and for distance square, that will be L to the power 2. All right. So L square. So dimensions for this I, it becomes ML square. All right. We know this dimension of I is ML square. Also alpha, we have written it in our notebook, that in towards when we have done the dimensions for some angular quantities, in which I have made you write this angular acceleration also. Just after angular velocity, we have done it, and its dimension is t minus 2. All right. So dimensions for the terms in RHS, now we can find out, because the term involved in RHS is I alpha. So I alpha dimension we can easily finding first writing the dimension of I, that is ML2. We have just derived it, and for alpha we can write t minus 2. The dimensions for alpha is t minus 2. You can check it in your notebook. It is t minus 2. All right. Now the dimensions for I alpha becomes ML2 t minus 2. All right. This t minus 2 it got multiplied by this one. You can see the dimensions for tau is equal to ML2 t minus 2, and for I alpha also it is ML2 t minus 2. So now we can say this, that the equation is dimensionally correct, because the terms that are involved in the right hand side, they are having the same dimensions as the terms towards the left hand side. The dimensions of RHS, they are equal to dimensions of LHS, and we can say that the equation is dimensionally correct. All right. So this is how we need to go in these type of questions. If you're having some doubts, you can easily be asking me. Okay, so I'm stopping a bit for around 30 seconds. If you are having some doubt, I can easily be solving them for you. In example 3, we are given some different language of the question is being given, and we have to proceed by the same way in which we have done the other examples. So let's do this. Rule out or accept the following formulae for kinetic energy on the basis of dimensions. So you are given two formula for kinetic energy. One is 3/16 mv square, or other one is half mv square plus ma. All right. So they are saying you have to tell that which one of these can be the dimensional formula for kinetic energy. All right. So which one of them can be the formula? All right. Dimensionally, which one is correct? That's what we need to proceed. So first, we need to find the dimensions for kinetic energy. So dimensions for kinetic energy, that is kinetic energy is the left hand side term. So we can be writing kinetic energy equal to this, or kinetic energy equal to this. So first I'm going for this one. The dimensions for kinetic energy is what? ML2 t minus 2. Kinetic energy is some kind of energy, and energy is having the dimensions that of work done, that is equal to ML2 t minus 2. All right. Now we need to find the dimensions of the terms in this formula, that is for part 1. So dimensional formula for part 1. So that is 3/16 mv square dimension. M is having capital M, and V square. V square means LT minus 1 squared. And when you square LT minus 1, it comes out to be L2 t minus 2. And finally, you can write it like this, that the dimensions of this 3/16 mv square is what? ML2 t minus 2, and it is equal to the dimensions of kinetic energy. So we can accept this formula. Hence, this formula is acceptable. Why so? Because the dimensions of kinetic energy are matching with the dimensions of this formula. We can accept it. All right. So this formula is acceptable. That is 3/16 mv square. It is being asked in the question, rule out or accept. We have accepted that this can be a formula for kinetic energy on the basis of dimensions. Now we have to go for the second equation that is given to us, second formula that is given to us. So let's go and proceed in this manner. All right. Okay. Chaitanya is asking me that what is the number is else than 316. It may be any number, because number do not have any dimensions, and we are checking only the dimensional consistency of the formula, not the exact formula. All right. So this is one limitations of the dimensions actually, that we cannot get the exact formula. We are not able to find out the constants that are involved in the formula. We can only be knowing that whether the formula is dimensionally correct or not. All right. So it may be any number and it will be dimensionless. Whether it is 2 by 5 or 8 by 9, whatever it may be, it will be dimensionless. Numerical constants are always dimensionless. Now, dimensions of formula. Second, we need to find. So let's do this. Half mv square plus ma. So dimension of half mv square. That is, half is not having any dimensions. M is what? Capital M, and v square is L2 t minus 2. Because Lt minus 1 is v, velocity is Lt minus 1 dimension, and square to it is L2 t minus 2. All right. And square to it is L2 t minus 2. Now, for ma, we need to go for this ma. So m is mass and a is acceleration, that is Lt minus 2. Now you can see this. So here is the catch, that this term, that is ma, it is not having the same dimensions as that of the kinetic energy. The first term is okay, that is having ml2 t minus 2. These are the dimensions of kinetic energy. But the second term is not having the dimensions of the kinetic energy, because 1l is less. It is only having dimensions as mlt minus 2. So we can write it like this, that the dimensions of RHS are not equal to the dimensions of LHS. They are not equal in this case. And hence we cannot accept the second formula. All right. So hence the formula cannot be accepted for kinetic energy, as the dimensions are inhomogeneous. Okay. The principle of homogeneity is violated over here. All right. So that's why we can say that we cannot accept the second formula. All right. So if someone is saying that the voice is not clear, so it may be the problem with the internet connection of few people, because others are not complaining about it. So is my voice audible to all? Please respond. So all of you are getting my voice. So that there may be some problem with someone's connection. That's why he has written the message. So let's move towards another example, or these are the three examples that I have discussed for the third application of the dimensions, that is to check the dimensional consistency of the equation. Now we need to go for another application of the dimensions, and this application is really very useful and we will be using it a lot. That is to convert one system of units to another. For example, if some quantity is given to you in SI unit and you need to convert that quantity, the value of that quantity actually, to CGS or some MKS unit or some other system, you can easily be doing that with the help of the dimension. All right. So this is really very important. We will be needing it a lot to convert some quantity value that is given in one system to some another system, or maybe to some new system. All right. So for this, the working rule will be like this. So please write it in your notebook along with me, and you have to solve it along with the slides. Then only you will be able to understand it properly. All right. So it is based on the fact that the magnitude of a physical quantity remains the same in every system of measurement. All right. See, for example, if I'm measuring something in SI system, for example, I'm measuring 1 kg in SI system. So I've measured 1 kg in SI system. But if I have measured the same quantity in the CGS system, the magnitude will remain the same. Only the units get changed. All right. The magnitude will remain around 1000 gram. 1000 gram is equal to 1 kg. We know this. So the magnitude, it is the same, but the units get changed in the different systems. So that's what it is based on the fact. And we need to use the following formula for the conversion. So this is the formula. Please write it in your notebook that we have to use. N1, M1 to the power A, L1 to the power B, T1 to the power C, that is equal to N2, M2 to the power A, L2 to the power B, and T to the power C. So I will be explaining that what are the terms which are involved in this formula in this slide only. So please write it in your notebook, and then I'll be explaining it to you that what are this N1, N2, M1, M2, L1, L2, T1, T2, and ABC. So that's what the quantities that are involved in the formula. N1 is one quantity, N2 is another quantity, M1, M2, L1, L2, T1, T2, and ABC. That's what we need to know. Then only we can use this formula. So what is N1? N1 is the numerical value of the quantity in system 1. So if I am given first system and which the numerical value of the given quantity is N1. Similarly, N2 is the numerical value of the quantity in system 2. All right. Say for example, this N1 in SI system and N2 in CGS system. So I can easily be converting from SI to CGS or from CGS to SI. All right. Or to maybe some any other system, maybe in FPS system or maybe in some new systems. All right. So this N1 is the numerical value of the quantity in one system that is given to you, and N2 is the numerical value of the quantity in system 2. Now what is M1, L1 and T1? They are the fundamental units of mass, length and time respectively in system 1. All right. So they are the fundamental unit of mass, length and time in system 1. All right. So one off was missing, so I've just made it right for you people. So M1, L1, T1 are the fundamental units of mass, length and time respectively in system 1, and M2, L2 and T2 are the fundamental units of mass, length and time respectively in system 2. Let me take question from Srishti. She has raised hand. Okay, Srishti, I have unmuted you. Go ahead with the question.
सर जो पहले आप फॉर्मूला बता रहे थे उसमें भी m का मतलब मास था.
Beta, this is the first class you are taking?
Yes, sir.
So please go through the other classes and then only you're going to know about these things. Okay. And this M1 is the dimensional symbol. In the previous one is the dimensional symbol. All right. So I have made you understand about those things. Please go through the video lectures, and still if you are having some problems and doubts, please contact me. All right. I'll be just explaining it to you.
Yes.
All right then. So this is something that you have to keep in mind, that what are M1, M2 and L1, L2 and T1, T2. So M1, L1, T1, they are the fundamental units of mass, length and time respectively in system 1. And for system 2, M2, L2 and T2 are the fundamental units of mass, length and time respectively in system 2. See, what do you mean by fundamental units of mass, length and time? Say for example, if system 1 is SI system. So M1 is what? 1 kg. Fundamental unit of mass in SI system is 1 kg. Similarly, L1 is 1 meter because fundamental unit of length in SI system is 1 meter. Time is T1 must be equal to 1 second because for SI system the fundamental unit of time is 1 second. Now, if this your system 2 is, say for example, FPS system. So for FPS system, the fundamental unit of mass is what? Pound. So M2 is equal to pound and L2 has to be equal to feet or 1 foot, and T2 is second, that is 1 second. Are you getting me that what I'm trying to impart? If it is CGS system, then M2 is equal to 1 gram. Fundamental unit of mass is 1 gram in CGS system, and L2 equal to 1 centimeter. That is fundamental unit of length is 1 centimeter in CGS system. If the system 2 is CGS, and then T2 is equal to 1 second because it is second only. All right. So that are the M1, M2 and L1, L2, T1, T2 in this formula. And now we have to tell you about A, B and C. So what are A, B and C? So A, B and C are the powers of the dimensions of the physical quantity whose numerical value is to be converted. All right. Fine. In almost every system, time is measured in seconds. So that's why the fundamental or the base unit of time is second only. There may be some new systems in which I have created, say I can say that this is my system, and in this system I will be measuring the time in minutes only. So then I have to take the base unit as minute. All right. I hope that I have answered Barkha's question. And now we need to know that what are these A, B and C. So these are the powers of the dimensions of the physical quantity whose numerical value is to be converted. All right. Say for example, if we need to convert force, that is Newton, into Dian. So the physical quantity that is involved is force, So we need to write the dimensions of force. So for example, if physical quantity involved is force, then write the dimensions of force, that is mlt minus 2. And now, what is the power of m? That is 1. So A becomes equal to 1. What is the power of L in this quantity? That is 1. So B becomes equal to 1. And what is the power of C in this quantity? That is minus 2. So C becomes equal to minus 2. So for this quantity force, the value of A, B, and C is what? 1, 1, and minus 2. All right, you can compare it. Fine. You can compare it from these two things. So whatever be the quantity involved, you have to write the dimensions for those quantity, and the powers of the dimensions of the physical quantity will be the value of A, B, and C. All right. So this is one example that I've done. Now let's move towards the examples in which we need to convert one given system to some another system. All right. So this is my solved example 1. I hope that you have written the formula, all of you, and we will be proceeding it on the basis of that formula. So example is given as convert 1 Newton into Dian. All right. So we need to convert this 1 Newton into Dian. So we know Newton is the SI unit of SI unit. All right. And it is the SI unit of force. So the quantity involved is force. And Dian is the CGS unit of force. We know this. So we need to convert SI system to CGS system. So our system 1 is SI system and system 2 is CGS system. So for these kind of questions, you need to proceed it like this only, that make 2 columns. All right, make 2 columns. And in the first column, write the first system, that is your SI system. And in towards the second column, write the second system, that is your CGS system. In this case, it is this thing. There may be something new. All right, there may be this thing that you need to convert CGS to SI, then you will be interconverting it. Fine. So we need to convert 1 Newton into Dian. It means the numerical value N1 in first system is what? 1. We need to convert 1 Newton to Dian. So the value of numerical value of the quantity that is needed to be converted is 1. So N1 equal to 1. Now M1 is the base unit for SI system, and that is equal to 1 kg. Mass is measured in kg in SI system, and this 1 kg that is equal to 1000 grams. We know this. All right. I have converted it because we will be using it later on. Fine. So do it like this. N1 is the numerical value of the quantity that we need to convert. We need to convert 1 Newton. That's why I've written 1 over here. Now we need to write the base quantities of SI system. So for SI system, we are having mass is measured in kg. So I've written M1 equal to 1 kg, and that is equal to 1000 grams. Similarly, L1, that is length, is measured in meter in SI system. So I've written L1 equal to 1 meter, and that is equal to 100 centimeters. Now again, I need to write the value for time. So time is measured in seconds in SI system. So it will be 1 second. So no need to convert it. Now you need to write the same things for CGS system. So we need to convert 1 Newton to Dian. It means we need to get some numerical value of 1 Newton into CGS system. That numerical value is not known to us. So we will be writing N2 is equal to question mark. We don't know about this. We need to find this N2. Similarly, M2 is the base quantity of mass for CGS system, and in CGS system, mass is measured in grams. We will be writing M2 is equal to 1 gram. Similarly, for base system of length, or the base unit of length in CGS system is centimeter. So L2 becomes equal to 1 centimeter. And T2, it is the time, and for base unit of time in CGS system is second only. So we'll be writing T2 equal to 1 second. So this is our first thing that we have to do whenever we are getting this kind of question, to convert one system into another system. All right, we need to write all these values because we will be using them in the formula that we have just written. Now we need to get the values of A, B, and C. And for getting the values of A, B, and C, we need to write the dimensions of the quantity that is involved. So the dimensions of the quantity that is involved is what? Force. Because force is the SI unit. Newton is the SI unit for force. So the quantity involved is force. The dimensions of quantity involved, you should be writing force is equal to ML T minus. All right. Now you can get the values of A, B, and C. Okay, when we'll be using the formula, we can easily compare it with the dimensions of the quantity involved and we'll get the value of A, B, and C. Now, using formula, this formula I have made you write N1, M1 to the power A, L1 to the power B, P1 to the power C, that is equal to N2, M2 to the power A, L2 with power B, and T2 with power C. So that was the formula that we need to use. All right. Is it all right or not? Now we need to find the value of N2. All right. And N2, it becomes equal to what? This whole term goes into the denominator. This implies this. N2 is equal to what? N1, M1 with power A, L1 with power B, and P1 with power C divided by these complete things. That is M2 with power A, L2 with power B, and T2 with power C. That's what I have written over here. I have just made these complete terms M2, L2, and T2 to go in the denominator of this term. All right. Now, what are the values of A, B, and C? All right. We know the value of A is 1, value of B is also 1, and value of C is -2. All right. So we will be writing it. But before that, we will be more modifying it, this equation, in a more efficient manner. Say when we know this thing, that when the powers are same and the coefficients are different, then the powers, we can write them as a whole power. Say for example, x square upon y square. We can write them as x upon y whole square. All right. So that's what I will be doing. Can't we do this? That if we are having x cube upon y cube, we can write it like x upon y and complete bracket and a cube. That's what we can do. So similarly, I'm having m1 to the power a divided by m to the power a. So we'll be writing m1 upon m2 to the whole power a. That's what I have done. Okay. So you can see it. The formula gets modified like this. M1 upon M2 having whole power A, L1 upon L2 having whole power B, and T1 upon T2 having whole power C. All right. So this is what we are left with. Now put the values of M1, M2, L1, L2, T1, T2 from the table that we have drawn earlier, and also the values of A, B, and C from our quantities dimensions that is involved. So here A is what? 1, B is what? 1, and C is what? -2. That's what I've done. In place of M1, I have written 1 kg because M1 was 1 kg. All right. In place of M2, I have written 1 gram. So M2 was 1 gram. So I've written it. In place of L1, I have written 1 meter. It was 1 meter. L2, I have written 1 centimeter. L2 was 1 centimeter. And in place of T1, I have written 1 second. In place of T2, also I have written 1 second. And the power, I have taken it from the quantity involved. A is having 1, L is also 1, and T is also having power -2. So A is 1, B is 1, and C is also C is not 1, C is -2. All right. So that's what I've done. Now this 1 kg is equal to 1000 gram. I can write in place of 1 kg, I can write 1000 gram. In place of 1 meter, I can write 100 centimeters. That's what the conversion I've done. All right. So in the next equation, I can write it like this. That, and in place of N1, I have written 1. All right. So N1 was 1. Our numerical value that was given to us, which we need to convert, that was N1, and it was 1. So now this gram get cancelled out with this gram because this 1 kg I have written it as 1000 gram, and G gets cancelled out with this gram, get cancelled out with this gram. Also 1 meter I have written it as 100 centimeter. This centimeter gets cancelled out with this centimeter, and the second gets cancelled out with this second, and you are left with N2 is equal to 1000 to the power 1 multiplied by 100 to the power 1 multiplied by 1 to the power -2. So I can write it like this. 1 multiplied by 1000 multiplied by 100, because 1 is having some power, it will be 1 only. All right. It will be 1 only. Fine. All right. So N2 is equal to 1 multiplied by 1000 multiplied by 100. So I can write it like this, that N2 equal to 10 to the power 5. Isn't it? So 5 zeros are there. So I can write it like this. And finally I can write my answer that 1 Newton is equal to 10 to the power 5 times. Now I have obtained the second numerical value in the second system, and N2 becomes equal to 10 to the power 5. Okay. So I hope that this is quite clear to you, and this is how we can work to convert one system into another system. All right. So let's do one more example. Okay, let me stop a bit for around 30 seconds so that you will be able to write it up, those who have not written, and if you are having some doubts, you can easily be asking me. Okay, let's do one more example. Example number 2, it says convert 1 joule to erg. All right. So we know joule is the SI unit of energy and erg is the CGS unit of energy. So we need to convert SI system to CGS system, and the numerical value given to us is 1. So we'll be proceeding in the same manner. Always make 2 columns like this. Towards the 1 column, write the first system, that is SI system in this case, and CGS system towards the another side of the column. Towards the second column, I have to write the second system, and in this case it is CGS system. All right. And N1 is equal to 1. We know we need to convert this 1 joule. Also M1 is equal to 1 kg. Base unit for SI system is 1 kg. That is equal to 1000 gram. Similarly, L1 equal to 1 meter. Length is measured in meter in SI system, and it is equal to 100 centimeter, and time T1 equal to 1 second. Same things. Similarly, for CGS system, N2 is equal to, we don't know what is N2, we need to find out what is N2, and M2 is equal to 1 gram, because in CGS system, mass is measured in gram. L2, it becomes equal to 1 centimeter, and T2, it is equal to 1 second. Length is measured in centimeters in CGS system, time is measured in seconds. Our column thing is done. Now we need to write the dimensions for the quantity that is involved. The quantity involved is energy, and energy is having dimensions as mL2 T minus 2. We know this. The dimensions for energy is mL2 T minus 2, and this we will be using in order to find the values of A, B, and C. Similar thing we have to do using formula N1, M1 with power A, L1 with power B, T1 with power C, that is equal to N2, M2 with power A, L2 with power B, and T2 with power C. Now solve it for N2. So all the terms will be towards the denominator of this term. So N2 becomes equal to N1, M1 with power A, L1 with power B, T1 with power C, and in the denominator M2 having power A, L2 having power B, and T2 having power C. Now when the powers are same and the coefficients are different, we can write them as a whole power. That's what I have done. N2 becomes equal to N1, M1 upon M2 to the power A, L1 upon L2 to the power B, and T1 upon T2 to the power C. Now we can write the values of A, B, and C from this dimension formula. A is equal to 1, B is equal to 2, and C is equal to minus 2. That's what we can do. All right. And in place of M1, I have written 1 kg. In place of M2, I have written 1 gram. And in place of L1, I have written 1 meter. In place of L2, I have written 1 centimeter. In place of T1, I have written 1 second. In place of T2, I have written 1 second. With the powers, that is A is 1, B is 2, and C is minus 2. Now convert, make the conversion. Kg can be written as 1 kg can be written as 1000 gram. So do it. That's what I have done. It is 1000 gram. Gram gets cancelled out with this gram. This is 100 centimeter. The centimeter gets cancelled out with this centimeter, and second gets cancelled out with this second. And you are left with N2 is equal to 1 multiplied by 1000 multiplied by 100 to the power 2. All right. So that's what we are left with. And 100 to the power 2 is what? 100 multiplied by 100. We'll be writing it like this. that N2 is equal to 1 multiplied by 1000 multiplied by 100 multiplied by 100. And you will be getting N2 is equal to 10 to the power 7. Finally, I can write it like this, that 1 joule is equal to 10 to the power 7 erg. So this is what we need to do in the conversion of a quantity whose numerical value is given to us in one system, and we need to get the numerical value in some another system. All right. Example 3 is quite similar. So I am just skipping example 3 and leaving it to you to solve it. I have already solved it for you. You can easily be seeing it in the PDF that how to solve it. I'll be discussing example number 4 first. All right. So I hope that you have done it. And still, if you are having some doubts and queries, you can easily be asking me over here only. If you are not having some doubts, then I'll be proceeding towards example number 4 now. So example 3, I've solved it for you, but I'm leaving it to you on you people to solve it on your own. Although the solution is given over here, you can easily be seeing it, but I request you to please solve it on your own and then compare your solution with this one, and then you will be knowing that whether you are able to get the concept or not. All right, so this is the example 3. Let me proceed towards example number 4. That is quite different. And what the example 4 says, it says that we need to convert 1 watt to a new system with 100 gram, 100 centimeter and 1 minute as base unit. So now we are having some another system in which the base unit of mass is 100 gram, that is M2 is equal to 100 gram. Base unit of length is 100 centimeter, L2 equal to 100 centimeter, and base unit of time is 1 minute. So T2 equal to 1 minute. So that's what I need to do and to convert it in this manner. So let's do the solution. In these type of questions, what we need to do, we need to make 2 columns. So make 2 columns, and towards one side write the first system. Our first system is the watt. This watt is the SI unit. So the first system is SI system. All right. The SI system is written over here, and the second system, we don't know about this system, but it's a new system. So I should be writing it as new system. Don't write it as CGS system. It is a new system. So please write it as new system. All right. Let me write it for you. Somehow got missed. So now it is new system. All right. So new system and SI system. Towards the SI system, I need to write the values of N1. N1 is 1 because 1 watt needed to be converted to some new system. Now this M1 is what? 1 kg, because in SI system mass is measured in kilogram, and that is equal to 1000 gram. L1 is equal to 1 meter, and that is equal to 100 centimeter. Similarly, T1 is equal to 1 second. Time is measured in seconds in SI system, and that's why we have written it as 1 second. Now move towards the new system. We need to find N2. That is question mark. We don't know about it. We will be finding N2. And we need to write the base units for this new system. In the new system, mass is measured in with a base unit of 100 grams. So M2 equal to 100 grams. All right. Similarly, the base unit for length is 100 centimeters. So L2 is equal to 100 centimeter. And the base unit for time is 1 minute. So T2 equal to 1 minute, and that can be converted to second as 60 seconds. So our table work is done. Now we have to write the formula, but before that, write the dimensions of the quantity involved. So the quantity involved is power, because what is the SI unit of power? So I need to write the dimensions of power. The power is having dimensions as ML2 T minus 3. All right. Now write the formula. Using formula, N1, M1 with power A, L1 with power B, T1 with power C is equal to N2, M2 with power A, L2 with power B, and T2 with power C. We need to find the dimensions for N2. Make all the quantities in the denominator of this term. So N2 becomes equal to this. All right. So I have skipped one step in between. So I do believe there may be a possibility that you will be finding some N1 also is not given. So in that case, we will be finding N1. So that's not an issue with us, that whether we need to find N1 or N2 in this situation, because we can always make the systems according to our wish. I can be taking this new system as this one, and SI system as the second system. It depends on us what system I want to take as the first system or the second system. All right. You can also be writing it like this. Then you will be finding N1. All right. So if you write N2, M2, L2, T2 over here in the first column, then you will be finding N1. So no issue about that. All right. The formula is quite clear for the same. So this is what we have to do. We have to find the value of this N2, and for that we need to write the values of M1, M2, L1, L2, T1, T2, and ABC. All right. So let's do that. What is M1? M1 is 1 kg. So in place of M1, I have written 1 kg. In place of N2, in N2 I need to find. In place of N1, I have written 1 because N1 was equal to 1. In place of M2, I have written 100 gram because it was 100 gram. In place of L1, I have written 1 meter. In place of L2, I have written 100 centimeter. In place of T1, I have written 1 second. And in place of T2, I have written 60 seconds. That is, T2 is equal to 60 seconds. That's what I have written. And I have written the power of A, B, and C. That is A equal to 1, B equal to 2, and C equal to -3. After comparing with the dimensional formula of the quantity involved, I have written the powers of these terms, that is A, B, and C. Now we need to solve it up. Convert this kilogram into gram. So in place of 1 kg, I can write 1000 gram. In place of 1 meter, I can write 100 centimeter. And it is quite clear. All right. So please do this. And we can easily be cancelling this out. Gram gets cancelled out with this gram, and this 0 gets cancelled out with this 0. This 0 again gets cancelled out with this 0. Also, these two zeros get cancelled out with the zeros in the denominator, and centimeter gets cancelled out with centimeter. Second gets cancelled out with this second. So you are left with this thing that N2 is equal to 1 multiplied by 10, because in the first term we are left with 10. 10 to the power 1 is 10. And in the second term, I am left with 1 square. So 1 square will be 1. And in the third term, I am left with 1 upon 60 to the power -3. So 1 upon 60 to the power -3 is equal to 60 to the power 3. Because when it will go into the numerator, the power becomes positive. All right. So after solving it, it becomes like this: 60 to the power 3 multiplied by 1 square multiplied by 10 multiplied by 1. So it comes out to be this: 2.16 into 10 to the power 6. And finally, you can write that N2 is equal to 2.16 into 10 to the power 6 new unit of power. All right. So this is what some new unit of power in some new system. We don't know about the system, but we know this thing that the base units of the systems are these ones. So this is how we can proceed for the questions in which we need to convert one system to some another system. All right. So that's all I want to discuss for today's class. Okay. So I'll be taking up your questions if you are having some. Thank you for joining up the class, and I will be taking the class. Next class will be on Friday, I think. So fine then. All right. Before that, maybe a possibility that I'll be taking some problem solving sessions for you people. So I'll be letting you know about that. And thank you very much for joining up the class. Stay safe, stay blessed. Thanks a lot.